1 gram of DNA can hold about 215 million gigabytes of data. That is more than every movie ever made, in something smaller than a grain of rice. And now scientists have turned that molecule of life into a working computer memory. Here is how they did it, and why it could change how every AI system on Earth is built. Segment 1. The density problem. Every year, humanity generates more data, and the storage we rely on, flash drives and hard disks, is hitting a wall. They consume huge amounts of energy, and there is a fundamental flaw built into them. The place that stores data and the place that processes data are separate, so information constantly shuttles between them. That movement costs energy, creates heat, and slows everything down. Nature solved this differently. In a brain, memory and processing happen in the same place, and the molecule that stores the instructions for life, DNA, turns out to be the densest storage medium we know of. Segment 2. The two ingredients. To build their device, the researchers needed two things. The first was synthetic DNA, short genetic sequences made from chemically engineered molecules designed for specific electronic jobs rather than to code for a living thing. The second was perovskite, a crystalline semiconductor already used in solar cells, lasers, and data storage. On its own, perovskite is promising but fragile. On its own, DNA is incredible at storing information, but not great at conducting electricity. Put them together, and something remarkable happens. Segment 3. The memristor. They built a memristor. A memristor is a memory resistor. Unlike a normal resistor, which just slows down current and forgets everything when the power cuts, a memristor can remember the direction electricity flowed through it even after the power is completely removed. The researchers layered silver nanoparticles into their customized genetic sequences, then integrated that with thin films of perovskite. The silver-doped DNA and the perovskite formed biohybrid pathways that guided electrical current through the device. Electrons moved reliably through these pathways at less than 1/10 of a volt. For context, a standard wall outlet delivers 120 volts. This thing runs on almost nothing. Segment 4. Brain-like memory. Here is the part that matters most. Because this memristor can store and process information in the exact same place, it works more like a neuron than a flash drive. In your phone, the memory chip holds the data and the processor does the math, and data has to travel between them constantly. In this DNA device, the data does not travel. It stays put and gets worked on right where it lives. That could support far more simultaneous and sophisticated processing, the kind of parallel crunching that AI systems desperately need. Segment 5. The numbers. The performance is stunning. The device uses 100 times less power than a traditional flash drive, and it actually holds more data in the same space. It kept working at temperatures approaching 250 degrees Fahrenheit, and it stayed functional at room temperature for over 6 weeks, which is dramatically better than existing perovskite memory devices. It could do the same memory job as comparable tech while consuming only 1/10 of the power. Segment 6. Why it matters. This is not a curiosity. The biggest bottleneck in AI right now is energy. Training and running large AI models consumes enormous amounts of electricity. If memory could store and process information in the same place at a fraction of the power, using a molecule that packs 215 million gigabytes into a single gram, the entire economics of computing would shift. This is early. Commercial systems are still a long way off. But for the first time, someone has shown that the molecule that writes the code of life can also hold the memory of machines. That's it for this week. Subscribe to The Rowdy Times for more tech and science explained without the fluff.